Oh, okay. Spring break is over. Better check my email here at the old computer. Gmail. Message from Roy Getchell. School's out till May 1st because of the coronavirus. What's that? Coronavirus. 20,912 deaths. Oh. The number of total confirmed deaths in the United States has increased 2.4 times in the last 3 days. It says it grows exponentially. Exponential. That's like chapter 7, section 2 in the USCMP curriculum. Let's get it out! Okay, USCMP chapter 7.2. I think we can handle that. USCMP chapter 7 lesson point 2. Exponential growth. Get out of here, goldfish. Cute little bunnies. More like COVID-19 bunnies, am I right? Alright, we probably gotta read about this a little bit. Jakai, can you tell me what exponential growth is? Great, thank you. And Xander, will you tell me what the exponential growth equation is? Great, thank you. Okay, so let's see how bad this is. Remember that A equals, this is an A, I gotta get better tech. A equals P times 1 plus R raised to the T power. Remember, T is 3 days. Okay, so A would be the deaths in Haynes, P would be our principal, but in this case we're just going to say that it is patient 0, 1 fatality. 1 plus R was our growth rate, which we remember was 2.4. Okay, and we plug that into handy dandy TI-89, boom! So Y equals 1 times the quantity 2.4 raised to the X power. Now we make a graph of that. I'm sorry, let's make a table. And we go down. 4 days is 33 people. T is 5, 70 or 80 people. Down to 9. So when T equals 9, we have 2,641 dead people. So when T equals 9, Haynes is dead. And with that, I say we do some panicking. It's panic time! Panic time! Oh my goodness! Panic, panic, panic! We're panicking! Lock the door! Oh, that's right. It's Haines, Alaska. I just have some newspaper shoved in the hole where my deadbolt is, so I guess I better not panic. So why aren't we panicking and locking ourselves in our house? Well, because the data isn't that good. These are the mortality rates, not the infection rates. And keep in mind that COVID-19 is more like a common cold and it doesn't kill everyone that it infects. But those numbers are startling because it's exponential, not linear, right? Like we're not having 2 people infected every day. Every day it exponentially increases how many people we have, and left unchecked, eventually everyone would contract it. So the scary thing there is that Haines only has like 10 beds in the clinic, and very rapidly, in a matter of hours or days, we would fill up all those beds and people wouldn't get services. So the way that we can combat that is to lower that growth rate. And the way we can do that is through social distancing, or not attending school in the typical fashion that we know how. And really the best thing you can do is just wash your hands. Wash them, wash them, wash them. Just wash your hands. Why aren't you stopping this video and washing your hands right now? Instead, you're like picking your nose and then you're gonna rub it on something, and then if you get COVID-19, then it's gonna be all over what you picked your nose on. Don't do that. Wash your hands, don't touch your face. Okay, so here's your assignment. I want you to take that same formula, A equals 1 times the growth rate raised to t. I want you to take that formula and I want you to find out how many days it would take for Hanes to run into trouble, assuming we have 2,000 people in Hanes, but change that growth rate or that growth factor. So do it with 2.4 like I did in the example, then do it with 2, then do it with 1, do it with 1/2, and see if we can smush that curve down a little bit better. Okay, see you next time. Wash your hands.